I'm Dave Castley from Team 53, which is Vaskar, Brian, Dave, Lakshmi, and Tyler. And we are making a daily stock direction predictor tool. Some background about this project. Our goal is to gain an edge in the market by predicting whether the price of a specific index will be positive or negative for the following day, given the variables today. So with this small probabilistic edge, we plan on compounding at a high frequency, which will result in significant returns. The data we'll be using, we will be pulling from TradingView, which provides the intrinsic data for specific stocks. So we can get the variables directly for a stock, and then we plan on modifying them and engineering them to train our model. We plan on using, or we are using, a logistic regression model. So our dependent variable will be tomorrow's price relative to today. So that would be up, down, 0 for down, 1 for up. So the output will really be a percentage of whether or not it will, the price will be positive the following day. So our independent variables that we're getting from TradingView are the 5-day moving average, the 200-day moving average, RSI, ADX, volatility percentile index. And with that, we are able to create several engineered variables that we can use. And this is where we will be starting and modifying our model as needed.
Hi, this is Tyler Choe. So now that we have the variables and the data set ready for our logistic regression model, we wanted to first split the data into a training and test set that we can later use when we're trying to identify prediction accuracy. So we took two different approaches for this. The first one was a chronological split, and then the second one was a stratified split. Before getting into the training and test, kind of the baseline was for our data set, we saw that the dependent variable column had 54% of up samples and then 56% of down samples, indicating that 54% of the data set was had an up for the up-down indicator, and then 46% had a down for that up-down indicator. This means that our baseline was 54% for measuring model accuracy, and that means that if someone just guessed up for every single day, they would be correct 54% of the time. But moving into the different training and test splits, our first one was a chronological split, which would be splitting the data into two different timelines. The first data set from 2013 to 2019 would be the training data set, and then the latter part, 2020 to 2022, would be the test data set. The major advantage for this is that we would be using the more recent years for the test data set, and thus that would be better prediction for the near future. The main disadvantage is that the training data set was during a healthy, stable economic period, and then the test data set was during the COVID years, which had a much more turbulent and unstable economic environment. The stratified split was something we did after the chronological split, and earlier I mentioned that the overall data had a 54% uptrend and 46% downtrend, and this stratified split was really to help reduce selection bias in the overall training and test data split, and using that that proportion in both the training and test data set. So our model results, after we ran the logistic regression model using the training and test data set, we found that the prediction accuracy was about 55%, which is pretty much in line with what the response or dependent variable was already at, around that 54%. So we took a different approach and tried to model using cross-validation. One of the main things that we were trying to do with cross-validation was to help eliminate selection bias and also help eliminate any overfitting that we might have with our model. After running the same model using cross-validation, we got actually a similar model accuracy again of 54%. And this is once again in line with the previous model that we ran, and then also with the response variable from the beginning. So overall, not any large improvement from the initial response variable. And some of our next steps are we're going to take a look at the variable selection and the model that we have currently and see if we can make some refinements to that. We're also interested in adding more data sets in and some other variables that we were taking a look at through the process, and also removing some variables that don't add as much value. We're also interested in testing some transformations, whether it be a log transformation for variables, and see if that will help in our prediction accuracy. And then finally, we're also interested in trying an SVM model and seeing if that may better handle the more nonlinear interactions that are present in the market data. And lastly, this is an appendix for the 3 different research papers that we looked at. And this really helped us in the beginning with a lot of scoping and understanding some of the limitations and best use cases for the data that we had, and some ways that we can apply it to the model that we were exploring. Thank you.